Right. So as we see here now, right. So as we see here, um, similar questions are asked in IGCSE O level chemistry papers. Which fraction has the lowest boiling point? Refinery gases. Because refinery gases are smaller in size, so therefore they are intermolecular interactions. So you know most of these are hydrocarbons. There can be some exceptions. So all mentioned here are hydrocarbon uh, molecules. So when it comes to hydrocarbons, the only intermolecular interaction is um, IDID forces. That thing you are learning only in A levels. But remember, for now you can keep this in mind. Weaker intermolecular interactions are there because the molecule is smaller in size. Which fraction is the most viscous? The most viscous one is having the least boiling point. Is it right? Is it fuel oil or bitumen? So why it's fuel oil, right? So you don't do these mistakes, right? No, no. Yeah, you are written down the answer it as fuel oil, right? Bitumen should be the answer. Write a chemical equation for this cracking reaction. C18H8 18, and the remaining carbons and remaining hydrogens can be octane and one other product. Cracking of octane produces octadecane produces octane and one other product. So one other product, remaining carbon and hydrogen can be placed there. Now here this one is also uh, this one is an alkane. So the remaining one must be an alkene because cracking is done to produce alkenes. Explain why it is important to crack lone chain hydrocarbon fractions. Because what lone chain hydrocarbons are less useful, short chain hydrocarbons are most useful and rare and expensive. Right? This is there are many applications more useful. Um, I can't read what you have written down here. Can you read it to me? Okay. Greater supply, I can give marks. Demand. Now, this is actually, so you have to, when you are writing it down, you have to write a general application. Now, you mentioned about uh, ignite easily. And it can, so can you tell me the connection between this? Where did you learn this one? Ignition and the lower boiling point? Can you explain it to me? So why having lower boiling point is useful? You can't say it is useful. Sometimes it is not even useful. It depends on your application. Sometimes having a lower boiling point is not a useful feature also. It depends on your application. If it is getting vaporized quickly, sometimes it is a disadvantage. So I can't accept this answer, right? Having a lower boiling point, you can't tell its advantage. Huh? Ignite easily is not a general answer. Ignite easily for what? Ignition means what? You have uh, petrol and diesel, right? Octane count, high octane count petrol, right? So when it is shorter in length, the ignition is more smoother. So this answer is not a general answer actually, right? So now remember in sciences we are write the most appropriate answer, right? This one is fine. I can give you 1 mark. Can you tell me one more general answer to summarize it? Lower supply, so that is why you need to make it. What else? Shorten. Can't you remember when it comes to alkene? Now, if you can remember, we were talking about a special reaction. Only alkene now participate. Polymerization reaction. Can you remember? So you can have polymerization reaction with alkenes, right? And actually, these are at what? These are uh, unsaturated. So therefore, there are many reactions. You can change it to many forms. So in general, we can write it has more industrial applications. So always try to write a general point because when it comes to that, they are asking about the general answer, right? They are not only asking about what having high octane count. They are not asking anything like that. So your answer must be general, right? Okay. There are many applications like you can do polymerization, halogenization. Since there are these are uh, unsaturated, unsaturated hydrocarbons, right? So you are getting only 1 mark there. Write a chemical equation for this incomplete combustion of octane carbon monoxide. Now remember as right. Uh, okay, very good. So you have balanced it properly. As a habit, always write the states. I am telling you for a reason. Sometimes in some marking scheme they expect you to have the states, and if you do not make it a habit, when you move on to A levels, you are in trouble, right? Always make sure to balance the equation with the states, right? So in few months, 10, 11 months, you are in A levels actually, right? So always start this one, this one, that hard. This one is also, since it is happening at room temperature, it's a liquid. And here you can call it as, yeah, it's a liquid. Yeah, crude oil procession. Procession is called fractional distillation. Very good. Describe the differences between crude oil and kerosene. In your answer, you should refer to. Can you read it to me? Mhm. Mhm. Crude oil. Okay. Describe the differences between crude oil and kerosene. In your answer, you should refer to average size of the molecules in two liquids, kerosene and yeah. So now both are right. Now even kerosene is also a fraction. It contains several hydrocarbons with not the same length with similar lengths. Crude oil it has much more larger range of hydrocarbon mixed. Right? Both are mixtures, but kerosene is having several hydrocarbons mixed each other, having similar chain lengths. Crude oil has many more different types of hydrocarbons in different chain lengths mixed to each other, right? So therefore, you can take kerosene average size. So average size in crude oil. It's a very good question. So larger size, yeah. So you can actually, I don't like the answer, but since it's O level, I would say okay. Crude oil has much larger average size compounds. Kerosene much less. So make it short and sweeter. Crude oil smaller size molecules. Kerosene larger size molecules. They are asking all to describe. Remember, describe and explain has two different meanings. If they ask you to explain only, you should tell the reasons. Which is bigger, which is smaller. Describe. Covalent bonding of the molecule. Kerosene and crude oil. Right. Uh, Now you can only tell about the number of covalent bonds because both are having covalent bonds, right? And even we can't comment on being saturated or unsaturated, right? This question is actually a very tricky question. So the only way to answer about it is kerosene has less number of covalent bonds in each molecule. In crude oil, since they have larger molecules, you can assume it has compounds containing larger number of covalent bonds, right? Viscosity, yes, definitely, since it contains larger compounds also, viscosity is much greater. So you don't need to tell the reason. Viscosity is greater in crude oil. Viscosity is less in kerosene. That's it. Here you can only comment on the number of covalent bondings. Crude oil more number of covalent bonds, less number of covalent bonds. So the second point is wrong. First point is correct. You are getting 2 points. So you lost 1 mark each of the two questions, right? Deduce the formula C9H20 pentane 5 CnH2 plus N. Pentane is an alkane. Draw the formula, displayed formula, very good. Repeating unit of chloroethene, very good. How does the condensation polymerization differ from addition polymerization? So still we have not done that. Condensation polymerization means uh, right, in the condensation polymerization water molecule is released, right? In addition polymerization no water molecule is not released, right? And water or even HCl can be released, right? And the other thing is the monomers are different. Two different monomers are used. Um, Same monomer, different monomers can be used, right? Uh, Addition polymerization can happen even in same and different, right? Okay. Yeah. So that's so at in your syllabus. So the best answer I would say a water molecule or HCl is released. No water molecule or HCl is released. Because if you comment on the monomer, even though it is not covered in the O levels, you got to write the correct thing. Even in condensation polymerization, same monomer can be used, right? Yeah. So for the same molecule, if you can have a esterification also can happen. Alcohol containing or the carboxylic acid containing a hydroxy groups OH group can be condensed. So therefore, same monomer can be there, even though it is not covered on the O levels. The most appropriate answer would be release of water or HCl in the polymerization process. So later now we are moving on to polymerization process. So there we can discuss further on this. Right. Okay. All right. Moving on to next one. Polychloroethylene and nylon do not biodegrade easily. What is meant by the term biodegrade? Can be broken down and and decomposed by microorganisms such as bacteria and fungi. Yes, can be broken down and or decomposed, can be decomposed by microorganisms such as bacteria. Right. Okay, that is also correct. 2 points. Decomposed or break down by microorganisms. So those are the two points. Right. What feature of addition polymerization make it difficult for them to biodegrade? Having a covalent bond actually. Covalent means uh, having a carbon-carbon bond. They are very unreactive, very good. That covalent bond between carbon and carbon, right? So your answer is very advanced. Uh, it is inert because of having a carbon-carbon bond, right? So actually you are at another level. You have given a level answer. So they are expecting something like uh, addition polymers are inert relative to condensation polymer products. Why it is inert? Why they are inert? Because carbon-carbon bond are less reactive. Carbon-carbon bond. Give me a second. Condensation, polymerization uh, with an alcohol. Yeah, so you have a ester bond here, right? So ester bonds are not formed between carbon and carbon. So I was rechecking your point. Yeah, that bond is not between a carbon and carbon, right? Your answer is precise. Very good. Why a market demand for gasoline fraction greater than that for the fuel fraction? Gasoline is yeah. Okay, we will continue from here next day onwards, right? So I'll end the class for today. Take care. Bye bye. Right.